Classical physics relies on a specific image of the universe, a static, empty stage where objects exist and forces act across a vacuum. Newton's law of universal gravitation describes the result of this setup, an invisible string pulling two masses together through the nothingness. This flat Earth ruler of physics holds up when calculating the orbit of a moon or the arc of a cannonball, but the math starts to fracture when applied to the high velocities of the deep cosmos or the frantic scales of the quantum world. Our equations fail because they treat the space between objects as a literal zero. If the medium itself has properties we aren't measuring, then the foundation of our classical model is incomplete. To bridge the gaps in our understanding of gravity, the scientific establishment is searching for a fundamental particle of the force, the graviton. This search requires machines of immense complexity, underground rings spanning miles that smash matter together to see if a physical carrier pops into existence. Decades of these experiments have yielded no such particle. We are hunting for a localized object to explain a force that may instead be a property of the entire system. Superfluid vacuum theory suggests an alternative. The vacuum is not an empty coordinate system, but a hyperdimensional, high-viscosity liquid. Gravity, in this framework, is a byproduct of how energy moves through this fluid medium. When you view space as a liquid, gravity shifts from a pull to a mechanical displacement. Inserting any mass into a dense fluid forces the medium to push back against the object from every conceivable angle. This inward pressure is the total pressure of the vacuum, the omnipush. The liquid universe is constantly pressing inward to fill the displacement created by the mass. From our perspective on the surface of a planet, this relentless atmospheric pressure of the vacuum feels like a downward pull. Think of mass moving through the universe like a spinning coin dropped into a pool. As the coin drops, its motion through the high-viscosity liquid creates a low-pressure hydrodynamic wake behind it. Fast-moving objects in a thick medium create cavitation, a trail of vapor bubbles that marks the path of travel. In this model, these persistent trails of nothingness are what we call strings. They are the topological defects left in the fluid as energy tunnels through the vacuum. These cavitation wakes are not solid objects. They are acoustic signatures, the memory of motion vibrating within the thick fabric of space. We have spent the last century studying the wake, the cavitation bubbles, while largely ignoring the liquid medium that created them. Attempting to measure a dynamically curving fluid universe with linear three-dimensional math is like using a straight ruler to calculate the length of a wave. Because the ruler cannot account for the curve, the measurement is consistently off by a degree. To compensate for this missing data at a cosmic scale, we invented dark matter to act as a mathematical patch for the weight we couldn't see. By only measuring the foam on the surface, we have miscalculated the total mass of the ocean. The mechanical view of the universe established by our predecessors treated space as a passive stage for matter, but matter and space are a single hydrodynamic system. If mass creates a displacement, then sustained energy creates rotation. On a fundamental level, every solid object, including a human, is a localized vortex, a stable spin within the liquid fabric. Factoring in the properties of this liquid medium provides a physical mechanism for the inward push of gravity and vibrating trails of string theory, framing the universe as a dynamic, pressurized engine.